Hi guys, welcome back to Weekend Dev Challenge by CodeChef. In this, every week we'll be posting hands-on dev challenges to improve skills in coding. So welcome to week 13. So let's see the problem statement what this says. So this has 6 parts. Let's look into the part 1. So it says this project series focuses on applying and comparing different classification algorithms such as k-nearest neighbors, SVM support vector machines, and naive-based classifier model for the Iris dataset, which is a standard dataset of uh, flowers, etc. So now we'll be understanding how each of these algorithm works. So in this first part, we'll be seeing KNN. So, okay, how do we start KNN? They're given certain steps. Exploring, understanding the structure of the data set. First, we try to explore and understand how the data set looks. What is the number of rows, columns, etc. And then we'll be handling missing values using and encoding the categorical variables. So then we'll be applying standard scaling. We'll be normalizing everything, and then we'll train the KNN model and then test with the different values of k. So let's look into the code. So we have a function called load iris data. So in this, first what we have done is we'll be loading the iris data set as a data frame. So then we'll be assigning it to a variable called df. So then we'll be using fillNA function to replace missing values with the mean. For example, if there is certain missing values in certain columns, so it uses the mean and then of that column and replaces the missing values with the mean. Now we'll be using encoding. We'll be using label encoder and we'll be encoding the target column. So basically target column will be encoding using label encoder, and then we have to split the data set into whatever we're giving as input and whatever we're getting as output. So the input X would be everything except the target column. So the target column is what we have to get as output. So in this, we'll be splitting the data set into X, that is everything except targets, and Y is only targets. Now we'll be returning X and Y. So this ends the first function. So let's see the second function. So the second function is split data. So in this, we'll be taking a test size of 0.2. That is basically 80% of the data is used for training and the remaining 20 is used for testing with random state 42. So that what does that random state 42 mean? So it's basically we're using the same data to train and same data to test. We are not shuffling between the data to get a good result. So then what we'll do, from this we'll return test train split, and then will be the test size already given and even the random state is already also mentioned. So in this we'll be splitting the data set basically. So now we have scale features. So scale features is basically one is train and one is test. So in this we have to normalize all the things. So first we start with standard scaler. So which the standard scaler is basically used to normalize things. And now we'll be normalizing the train data set. That is X train. We'll be using fit transform so that it automatically finds patterns and it normalizes. And now here for test we'll be using only transform, not fit transform. Whatever the info it has extracted from here, it will be applying that to train our test data set, because it shouldn't know what already is there in the test data set. And now we'll be turning both test and train data scaled data. So now we have train KNN. So there is function called train KNN. So in this, the whatever the fields we require is X train, Y train, X test, and the value of K. So here we'll be taking the value of K as 5. Okay, so now we'll be using a variable KNN to bring in K near neighbors classifier model, and the number of K is already mentioned as 5. Now we'll be trying to train the model. We'll be trying to fit K X train and Y train. So we'll be trying to train the model. Then now we'll be guessing the value of Y predicted using the test data set. So basically we have X train and X test. So both are X train, Y train is trained. And now we have Y predicted and X test. So both are same. So using X test, we'll be predicting the value of Y. So using all the information that is there in the test data set, we'll be trying to predict the target, that is a Y. And now we'll be returning everything. So now we have evaluate KNN range. So in this, basically we are giving input all 4, that is X train, Y train, X test, Y test. And then the K values will be taking 5 values of K, 1, 3, 5, 7, and 9. So we'll be creating a dictionary called results, and we'll be iterating through every K in all the K values. And for each K, we'll be training the model again. We'll be trying to fit X train and Y train. And we'll try to extract the Y predicted, that is a target value that is predicted from the model. And we'll be trying to get the accuracy of that model and showing the accuracy in a dictionary form in results. So this is what we're doing here. Okay, so now we have the main function. So again the same thing, we're loading and pre-processing the data in this. In this, we're loading the data set, and then we'll be splitting the data set. We'll be scaling the features of all the data set, or all the features of the data set, and then we'll be training it for k equal to 5, and then we'll be evaluating multiple k values. So I'll run this. Okay. So we have the output k equal to 5, accuracy 1, k equal to 1, accuracy 1. So all the k values 5, 1, 3, 5, 7, 9, we have the same accuracy values of 1. Yeah, so let me submit this solution. So yeah, the solution is submitted. All the 5 test cases have been passed. So that's it for this video. I'll meet you in the next video.